Bismillahirrahmanirrahim. Today we are interested in solving one detailed question so that we know so many things regarding regression analysis. So for that, there is one file that is already there having data in it. It would be if I open this file. Okay, so we solved the same question, same data we used earlier in the previous lecture, where we found the estimators and so many other things. Okay, so there are different ways to find out the regression results. Let us revise few things in few minutes, and then we will proceed further. Okay, so first of all, you have to define the variables. Let us say you are going to say that salary is your dependent variable and you are going to denote it with y. Then there comes service, and service is your independent variable, that is we are going to denote it with x1. Then there comes age. Age is another independent variable and we are going to denote it with x2. Then there comes gender. So this is basically a dummy variable, and as I have already explained that the dummy variable is the variable that could only have two values. One is 0 and the other is 1. So you can write it as x4. Sorry, 4. Okay, is it visible?
Yes, sir, visible.
Okay, fine. So if I ask you to find out the estimators in this case, so basically the equation in this case would be like this: y equals alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus mu I, the error term. So this is basically the equation, and you are interested to find out the estimators. So definitely estimators would be find out if you will take into your account the sample data. So in that case, this equation will take the form y bar will equal alpha hat plus beta 1 x1 plus beta 2 hat x2 plus beta 3 hat x3 plus beta 4 hat x4 plus ei. Ei is basically the sampling error, okay, or residual value when we take into our account the sample data. So definitely as we take into account the sample data, therefore alpha hat, beta hat, we are interested in these parameters, these estimators. Okay, so if you see the first equation, this is the equation in which you will take into your account. This is basically the population regression function or population regression equation. Population regression line you can also draw from this equation. Uh, and the second equation, that is this y hat, this is the sample regression equation. And in this case, if you see hats are there. Fine. So this is the discrimination between these two. how we could find the estimators? If you take into your account the simple regression equation, in that equation we only take into our account two variables. One is the independent variable and the other is the dependent variable. So in that case, you are able to find out the values for alpha and beta, and you can also prove those, the formulae for those two, alpha and beta. But now we are interested in solving the question where we are concerned with multiple regression analysis. So multiple regression analysis means there are more than one independent variables are there in the model. So if you see this model, there are four independent variables. Out of these four, x3 and x4, these two variables are dummy variables. So I have explained the concept of dummy variable, that these take value 0 or 1, and you define these values deliberately. It's upon you that how you define that what is going to take value 0 and what is going to take value 1. Like in this case, if you see uh, job and gender. So somebody has job, somebody has no job. So you can give 0 and 1 in that case. Gender, if you are going to give one value to the male, then you can give 0 value to the female in this sense. Okay, then there are age and service variables. These independent variables, if you see, age is, let us say 42 years, 33 years, and so on. And service is like this, it is in months, not in years. So 93 months, 104 months, like this. So how will you find out the estimators? You can use straightforwardly here the data analysis and go to regression. Okay, press OK. This window will open and you will give the output range. This is the output range. Input range for Y, and then you are interested in giving the input range for X. So for X, you see all these variables are there. So you will write down it like this. Then you will press labels, because you know in the first row there are labels. Then you have to give the output range. So output range I'm going to give over here. And now you will simply press OK. And better would be if I have residuals and residual plot, so that I may be able to explain few more things. Also give me the normal probability plot. Okay. So this is the summary output. Okay, here you can see what will you see over here. First of all, you will see the F statistic, and in this case you will consider the null hypothesis, that is beta 1 is equal to beta 2 is equal to beta 3 is equal to beta 4. It means all betas are equal and all are equal to 0. Okay, that means that there is no relationship between the independent variables and the dependent variable. And the alternate hypothesis in that case will be all betas are not equal to 0. So we have already explained this concept, that if we reject H naught in this case, that will mean that we are going to accept the alternate hypothesis. So alternate hypothesis, if you see this significance of X or probability value of F statistic, so probability value of F you can say, or P value or significance of F, you can see that it is less than 5%. So as it is less than 5%, the level of significance you may set at 5%. So this is less than that. It means that you would have to reject H naught. The rejection of H naught will mean that you are going to accept the alternate hypothesis, and that is, you can see the statement over there, that at least one beta is not equal to zero, or you can say all betas are not equal to zero. Okay, so then you will go to check that which variable out of these four is insignificant. So if there is some insignificant variable, so you can explain that this is the insignificant, so therefore we are going to drop it, or we are not going to consider this anymore. So for that, you have to take into your account the t stat. So if you see this t stat, you can decide something about the null and alternate hypothesis that you have taken one by one. One by one mean that first of all you are going to take into your account the service months. So whether service months are affecting the salary. So you can see over here that t is more than 2. So the, you can say, there is some set pattern that if the t stat exceeds 2, we normally reject h naught. But better will be if you consider p value into your account. You have to consider this p value. If it is less than 5%, then you will reject h naught. Otherwise, you would have to accept it. So let us see what happens over here. Uh, Service x1, 0.01, it is less than 5%. So same result as you saw over here in case of t stat. So what will you do? You are going to reject h naught. Rejection of h naught will mean that beta 1 is not equal to 0. Once you have confirmed that beta 1 is not equal to 0, it means that in case of population, service affects salary. Okay, whatever is true in case of sample, that is also true in case of population. Then you will see the next, in the next row, it is 30% age. So what this means, it means that now you have failed to reject h naught. What was h naught? In this case, beta 2 is equal to 0 was h naught. Beta 2 if equal to 0, that will mean that uh, x2 has no effect on salary. So that is the case, because you are unable to reject h naught, means that you are going to accept h naught. Exception of h naught means that beta 2 is equal to 0, in fact, for population. So you will say that there is no impact of age on salary in case of population. Then there comes, let us say, gender. So gender, if you see 0.03 is less than 5%, it means that you are going to reject h naught. So rejection of h naught here will mean that yes, gender is important in determining the salary of a person. Okay. Similarly, if you see this job, I think this variable has been used for nature of job, let us say, or let us say we can say that this is the nature of job. So whether nature of job also determines the uh, salary or not. So in this case, as we are taking into our account this data, these data, so here it is 70%. So you can say that we strongly are unable to, you can say, accept, we are going to accept h naught. We are unable to reject h naught because it is 70%. And if you see, it is much higher than the level of significance that we have set as 5%. So as it exceeds and exceeds so much from 0.05 or 5% level of significance, so you will uh, accept h naught in this case, and that will mean that beta 4 is equal to 0, in fact, in case of population. So this parameter is equal to 0, so there is no impact of job on the salary. So in this way, you will first of all see that which out of the selected variables is going to affect the dependent variable. Okay, so now if you see, these are the residuals and these are the predicted salaries. Okay, so I have given the command to the Excel to give me these values. So predicted salary y, basically this is the y hat. What is this? This is the y hat value. And what are these residuals? These are the values against EI. Okay. And this is the percentile and salary. And if you move further rightward, yes, these two tables are there. So we will take into account these two tables later on. But first of all, if definitely in your examination, you would not have Excel before you. You would have to solve these things manually. So today we are interested to find out these things manually so that it become easy for you. It will become easy for you to find out things manually on your notebook. Okay, so we are basically interested in finding out the predicted value of y and residuals. Okay, so how will we find this? First of all, we are interested in finding out. So also, there are so many graphs that will help us in determining different situations regarding. So I think I should choose new sheet for this because there is no need to move these graphs downward. We will have to see these later on. So I'm going to use another sheet for this. Okay. So now, what will be the predicted value of y here? Let me make these cells visible to you. Okay. So how will you find out the value for y hat? First of all, see, write it down as y hat. Calm down. You are interested in finding out the residuals. So definitely there are four variables, and for four variables you would have, you would be at some, you can say, you will feel some inconvenience to write down the parameters or to find out the values of parameters. So as we are interested in doing things manually, so better would be if we find out the values, or we only take into account only two variables instead of four. So that will make things easy. Or if you are interested in making further, you can say, convenience, then you can only take into your account only one variable. So let us take two variables into our account because that will help us in understanding the multicollinearity issue and other issues. Okay, if you recall your memory, we have already solved similar question for one variable when we were discussing the simple regression function. Okay, so now I'm going to remove these two variables. You have seen that there would be some impact of the dummy variables when we use these in the regression analysis. But now we are basically interested in knowing things regarding, sorry, this is not the sheet that I have to change. I have to change this sheet. Okay. So I'm going to delete this. And I'm interested in y hat. How will you find out y hat? For this, the equation will be like this. Y hat is equal to, sorry, alpha. I'm going to use alpha instead of beta naught. Alpha hat plus beta 1 hat x1 plus beta 2 hat x2 plus ei. Fine. So this is the equation, and we are interested in finding out beta 1 and beta 2. So what is the formula for beta 1 and what is the formula for beta 2? Okay. So if you recall your memory, we basically derived the formula for uh, alpha hat and beta 1 hat. And we didn't derive the formula for beta 2. So let me see that how can we find out the value for beta 2. So basically that would be a detailed formula, and you have to prove that formula by taking into your account the matrices. Okay. When you take into your account the matrices of determinants, you will be able to find out the value for beta 2. So for simplicity, I'm going to use, boys, as you are not familiar with deriving, so I will suggest you to derive beta 2 at home. I think if somebody has derived, he may give me the formula. Otherwise, I will simply have to use the formula for beta 1 and alpha, beta 1 hat and alpha 1 hat. So let me see if there is some formula written on my notes for beta 1 and beta 2. Has somebody derived this? Try to derive the formula for beta 2. Are you listening me?
Yes, sir.
So, did anybody try
Sir, I will check it on.
the formula for beta 2? We know the formula for beta 1. Yes, I have found it in my notes. What is the value for beta 1? But that is a slightly complex formula. I'm going to write it down for you.
सर बीटा टू की वैल्यू लिख लें मैंने लिखी हुई है
Straightforward numerical value?
या न्यूमेरिकल नॉट सर वो जो
No
इक्वेशन
formula.
आपने लिखवाई थी
Yes,
बीटा
yes,
टू
yes. So
की
no,
वैल्यू
in that case, I was using beta 1 and beta 2. Beta 1 was intercept, and beta 2 was the you can say parameter for the first variable. So that was very simple. But if you are interested in writing down, let us say beta 2 hat, it will be like this. Beta 2 in this situation that we are discussing right now. Beta 2, the coefficient for x2. So in this case, when you will derive the formula for this using the matrices or using the determinants, so a big determinant will be there. And finally, you will have the formula like this: summation x1 square, summation x2y minus summation x1y summation x1 x2 divided by summation x1 square summation x2 square minus summation x1 x2 summation x1 x2 whole square for this. So you can see this is a big formula as compared to the previous formula that we had in case of beta 1. So if you recall your memory, the formula for beta 1 is very simple: summation x1 minus x bar multiply by y minus y bar.
यस सर। सर ये बीटा टू का फॉर्मूला नहीं है?
Basically, in that equation that we wrote previously, where we took it as beta 2, the equation was like this: y is equal to beta. We started from beta 1. So, beta 1 was the intercept, okay, and beta 2 was the coefficient for the first. And remember that you have to write down here I, and you can also write down here I, because you know this is the series. X1 is a series, so we are not writing here I, but better would be if you write down I here. Okay, so you can see here I have defined that beta 1 is the intercept in this case, and beta 2 is the coefficient for the first variable, and there is only one variable, one explanatory variable or independent variable. But if you see the current case, in current case or in the present case, beta 2 is the coefficient for x2. So therefore you are getting confused that this is the value for beta 2 head. So I can change these. I can also write down here a, b, c. Okay. So you have to remember that now for beta 1 as it is the coefficient for x1, the first variable. So for this, the formula will be this, that I'm going to write down: y minus y bar. So as you know, here in this case, you are taking into your account only one explanatory variable. So there is no need to write down x1 with this, right? And you have to divide it with summation x minus x bar whole square. Is it? Was this the formula for beta 2 that you have in your book, on your notebook?
Yes, sir. We have this for beta 2 in our
We
notebook.
have this one for beta 1. Okay. So now I'm going to rub this. This was the formula. Remember, this was the formula when there was only one explanatory variable in the model. Fine. So when there are two explanatory variables in the model, then the formula for beta 2 will be like this. Fine. And the formula for beta 1, that is the coefficient of the first explanatory variable. The formula for this in that case will be beta 1 hat, and you can prove these formulae using the matrices as I am saying. Okay, so this will be like this: summation x square, or you can say x2 square, summation x1y minus summation x1 x2. Okay, summation x2 y. So now it means that the formula will change. The denominator will remain same in this case: x1 square summation x2 square minus summation x1 x2 whole square. So you can see that when there are two explanatory variables, how formula will change. Okay, so similarly, when there will be three explanatory variables, the formula for each beta 1, beta 2, beta 3, and for alpha, the formula will change every time, right? So it means that this is the complex situation that you have to confront with if you are going to solve this question. Okay, so what could be done over here? Normally, examiners give the values for beta 1, beta 2, and beta 3, and also they give the standard errors for that. Okay, so if let us say those values are given, so then you can simply use those values. So let us use the given values. Okay, how we can find out the given values? As I have calculated these values using taking help of Excel, so it means that these values are there in front of me. Okay, so normally if you see in the question paper, these values are normally given. Okay, so if they are given, then we can take help of these values. So if we are interested in using those given values, then we can also use the other two variables that we have just rubbed or deleted. Okay. So I'm going to take into my account all these four variables now, because I will straightforwardly use the values that are there in the output that is given by the Excel. Okay, so how will you find out the y hat, the estimated value? How will you find out the predicted or estimated value for y hat? Okay, now you can write down the formula over here. So this is the output that is given over here. If you see this table, predicted salary, this is the predicted salary. So how the software has calculated this? Software has calculated it straightforwardly. But if examiner gives you these values, coefficients, okay, and you are required to find out the fitted values or predicted values, so you can find out how. You have to take into your account the equation, okay, regression equation for sample, and that was alpha hat over there. So what is alpha hat? This is alpha hat. Fine. Then you have to add alpha 2. Fine. And then you have to multiply this with what value? This is beta 1. So you have to multiply this with this value. Fine. Then that's plus, write down beta 2. So this is the exercise that you have to do on your notebook. Okay, you will write down the value for beta 2, and then you will come over here, and you would have to, why it is like this, sheet 1. Okay, fine. There is something wrong. I have to paste these values over here in such a way. Let me correct this, because the answer will be wrong in this case. Control C, or otherwise I'm going to delete this. Come over here, Control C, and here you have to paste these values. Paste values. Paste values, yes. Okay, so now we have these values. We paste it. So these are the values. So these values are normally given by the examiner. Okay, so now let us write the formula again. Equal to this value. Okay, so now you can see there is no sheet written over here. Okay, now because in that case the output was there, but there was some calculation behind that. But now these values are simply values, numbers. Okay, no formula is behind these values. Okay, so you have to take into your account the given values, but it is very easy when you will solve it on your notebook. Okay, so beta 35. Once I'm interested to write down the whole betas, and then I will give some special notations to the equation so that I have the exact answer. So this is alpha plus. And now you have to write down beta 1. This is your beta 1. Okay, and you multiply beta 1 with the x1, this is your x1, then plus, write down beta 3. So Nasrullah, I'm doing the whole exercise that you would have to attempt on your you have to write down on your notebook, because you are interested in doing things manually. Okay, otherwise we have all these things quickly using the Excel, or we can also use eViews or other softwares. But why we are doing this in detail? Because you have to do it manually. So just think that I'm doing things manually. Okay, understand?
Okay, sir. Thanks. Yes, 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 sir.
Okay. So then there is beta 2. And if you see beta 2, uh, sorry, yes, B2, this is address. This is the address of column. Don't think it as beta 2. It is address. Okay. Then comes the third variable, that is beta 2. And you have to multiply beta 2 with, here it is age. Okay. Then there comes the third variable. And for that, see, this is beta 3, and you multiply this with this value. So multiply with this value. So you will write down whole columns in this way. Okay, and you will multiply it, then you will find out the value for y hat. Okay, then there comes plus, and the final value is this value. This is beta 4. So beta 4, and you have to multiply this beta 4 with this x4. Okay, so now if you will simply press enter, you will be in trouble, because few values you have to fix. Okay, few values you have to fix, and to fix values, what strategy you will use? See, b35 is such a value that is written over there in the this is basically the cell address, and this is the cell address is 35. B35 is the cell address against which the alpha is given. So in all cases, when we'll come down and have different values as x1, definitely this is the series. So when you will take into your account x1, there will be correct answer. But when you will take into your account x2, there will be some problem, because the Excel will take the value that is written below this value. So it will take this value into its account. And similarly, it will go on taking into its account the values that are written below. So in some cases, you will have the values as undefined. So you have to fix this column. And to fix this column, you have to put the dollar sign here. And again, put the dollar sign over here. So it means that you are going to fix the column and as well as the cell. Okay. Similarly, you have to fix this value that is written over there in B36. So therefore, fix it and put dollar sign over here. Okay. And then you see B2 is there. So B2 is this value. So it means that when you will come down, it will automatically take 104 into its account, but it will keep this value, that is beta 1, as constant. Okay. Then come to the next value. Again, put dollar sign over here. Again, put dollar sign over here. So you are going to fix the column, this cell, and also fix this cell, this value. Similarly, fix this value. Okay. And there's no need to fix E2, because E2 will be the values that are written over there in this series. So it will take the values one by one. So now let us press enter and see what is the answer. So you can see it is 1823912. Okay. And then you can drag it down until the last row, and you will have the output in this way. Fine. Now let me show you the output that Excel gave me. Excel gave me this output. Okay. So for comparison, I'm going to take this these values from here. I'm going to copy it, and I am going to paste these values over here. Okay. So now you can see the values. Are they same?
Yes, sir.
Okay, so in this way you will find out the values on your answer sheet or notebook. Fine. So because these are the same values, so I'm not interested in keeping these values. I am just interested in y hat. Okay, then I am interested in finding out the residuals values. Residual values. And for residual values, if you recall your memory, we have the formula E is equal to y minus y hat, isn't it?
Yes, sir.
If you use this formula, you will be able to find out the residuals values. Okay, so residual values are very important. These will help us a lot in, later on when we will take into account the homoscedasticity issue and the autocorrelation issue in the model. Okay, so now we are interested in finding out the residual values. How will we find? It is very simple. You will simply write down here E and come down, uh, press equal sign, and now you are interested in having the difference of the actual value, that is the actual salary in this case, y, and you have to subtract the fitted value or the predicted value from that. Okay, so let us see what happens. Write down this value and subtract this value. Okay, so press enter. This is the answer. Okay, and then simply press it twice, so you will have all the residual values. Fine. So these are the residuals. Now if you want to compare these values with these residuals that are being given by the software, so you can simply write these values for a few seconds in the second sheet here. Simply you have to have the values. So now you can compare these two. So residuals, these are the residuals. You can see, is there any difference?
No, sir.
Values are same. Okay, and we
Yes, sir.
don't want to keep these values over here, so I'm going to delete this. So now once we have the residual value, then you are able to solve so many issues. Okay.
सर ये रेजिडुअल वैल्यू हमने कहाँ पे सॉल्व की थी?
Sorry.
रेजिडुअल वैल्यू हमने कहाँ पे सॉल्व की थी जहाँ पे वाई आई हैड और वाई आई को कंपेयर किया था?
Residual value is basically the difference of y minus y hat. What is y hat? Y hat is basically the predicted value for the explanatory variables. Okay, and difference of these two is the residual value.
सर वही जिसमें हमने स्केयरिंग एंड समिंग करके उसको सॉल्व किया था फिर मैट्रिक्स बनाई थी.
So that was basically for to find out the value for yi hat, because the values of yi, the actual values for yi we have given in the data. Yi series is given, but we were interested to have yi hat. Okay, and for yi hat, we were interested to find out the value for beta 1, the value for beta 2, the value for beta 3, how many independent variables are there. So according to the number of explanatory variables, betas were there, and for those we were interested to find out the values. Okay, so if there is only one explanatory variable, then you can simply write down the formula for alpha and beta. That are very simple formulae, and we proved those formulae in the class when we were face to face. So you can use that strategy as I used in the previous lecture. You can take recording of that. Okay. So, but in this case, if you see, there are four explanatory variables. We are basically discussing the multiple regression analysis. So definitely in this case, the formulae for alpha and beta 1, beta 2, beta 3, beta 4 would be some complex formulae. And if you go to derive those formulae, you would have so much time to consume. Okay, so therefore, normally the values for beta 1, beta 2, beta 3 are given when we are discussing the multiple regression analysis. Okay, so you are required to find out the residuals. If let us say beta 1, beta 2, beta 3, all values are given over there, so then you can find out the predicted value for y. Okay, how will you find out the predicted value? Using this formula that is written over there. So you will write down the formula, and then you will have the predicted value. So you will simply substitute different values in x1, x2, x3, x4. Similarly, in all values are written over there, 93, 42, 41. So in the you can say variable, whenever you are going to use x4, so you will put here 0, 1. So there will be almost if you see, there are 30 observations, so 30 equations will be there to find out the value for y hat. So for each equation, the value definitely will be different. So you can say this is the value that we have obtained using first situation or first equation, where we used x1, x2, and x3 and x4, but their first value. Okay, and then their second value, third value, fourth value, up to 30 values. So 30 equations and 30 answers are there. And then the residuals are there, and we have confirmed that the residuals are same as was required. Okay, so now this is the residual value, and if you are interested in knowing that whether these residuals are random or not, so you can plot these. Okay, so if you recall the situation where the variance was constant, so you will see that the blue property, Gauss-Markov theorem, that the estimators are blue, best, linear, unbiased, and estimators. So the assumption was that variance is constant over time. So if variance is constant, that means there is no issue of heteroscedasticity. Constant variance homoscedasticity is there, and that is required basically. But if variance changes over time, that means that the issue of heteroscedasticity arises, and then we have to address that issue, and remedial measures are there. So we will use those measures later on, but for the time being, you just simply have to have this value e into your account. Okay. Where are the graphs? These are the graphs. Uh, residual plot. So you can see any out of these. Let us say for this. Now you take it into your account this graph. So what these graphs are basically explaining better would be if we take into our account the assumption. First of all, basically, we are interested in knowing the multicollinearity issue in the analysis, whether it is there or not. So we will use this value E later on when we will discuss heteroscedasticity and autocorrelation. But now come to the assumptions that we have for multiple regression analysis, so that we may know that what is the benefit of having these residual values with us. Okay, how they will help us. But for that, better would be if we see the assumptions that are for multiple regression analysis. and when those assumptions are violated, some issues arise, and how we solve those issues, and how we see that whether those issues are there or not. So for that, better would be if we first see the assumptions. Basically, in case of simple regression analysis, we discuss those assumptions, and those assumptions are almost similar in multiple regression analysis. Okay, so you can write down on your notebook, because I am not going to write down each and everything over here. Write down assumptions for multiple regression analysis. So you have to write down assumptions for multiple regression analysis. Then what is the first assumption? The first assumption is there is a linear relationship. There is a linear relationship. I'm going to write it as R oblique P. So this means relationship. There is a linear relationship between the explanatory variables and the explained variable, or the dependent variable and the independent variables. There is a linear relationship. Okay, so whether there is a linear relationship or not, you can know this fact taking into your account the scattergram or scatter diagram. So if you take into your account the scatter diagram, then you will be able to know that whether the relationship is linear or not. Okay, so how will you draw the scattergram manually on your notebook? Definitely you will take y over here and x1. First of all, the first variable you will check. Okay, so you will put dots, different dots over here. You will see that what happens in this case. That is there any positive or negative relationship, or there's no relationship in between these two. Fine. So for that, as I have already explained in the class, that you have to write down the quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so mean values, mean of x1, mean of y, and then this is the quadrant, first quadrant, second quadrant, third quadrant, and fourth quadrant. So you will see that in which quadrants more dots are there. That you will first of all, you will have the mean values. Y bar will be here, x1 bar will be over here, and then you will see, let us say you are going to obtain dots, more dots in this quadrant and more dots in this quadrant. Okay, so this will explain that this is the positive relationship in between x1 and y bar. And if the situation is different, let us say this is the situation y, and this is x1, and you are going to take the average values into your account, and more dots are there in this quadrant, the fourth quadrant, and in the second quadrant. So there will be a negative relationship between the variables. So how can Excel give you the relationship between these two? Let us try solving this. Data analysis, and there is an option correlation. Okay, so correlation, and then press OK. You will have this. Write down here the input range for the first variable.
एक्सक्यूज मी सर, ये स्टेप दोबारा जरा कर लें.
See, basically I am explaining that first of all, you have to see that whether there is a relationship between these two values or not. And we are basically interested in linear regression analysis. So we are saying that we are interested in linear relationship. Okay, so it means that linear relationship means the line that you will draw as a sample regression line, that will be a straight line. It may be positively sloped, it may be negatively sloped. Okay, so if you want to have the blue properties there in the estimators, or you can say the estimators are blue, best linear unbiased estimators. So this property should hold, that the relationship between the independent variables and the dependent variable is linear. The relationship is linear. If you see such a situation which is not linear, let us say you draw the points and the curve is like this, the relationship is like this, it means that there is no linear relationship. And if you are going to regress the uh, explanatory variables or the dependent variable, and there is no linear relationship, then the estimators will not remain blue, they will be unbiased. Okay, so therefore you have to confirm that whether the estimators are you can say right or not, they should be unbiased. So if they become biased because of the linearity issue, then you will say that they are not trustworthy. We cannot depend upon the results that are being there. In case of, you can say, in this, whatever is there in form of predicted values, they are not correct because the estimators are not true, in the sense they are not you can say unbiased, because the relationship between the independent variable and the dependent variable was not linear. So the linearity must hold if you are interested in having the true estimators. Okay, so for linearity, how we will see, I have explained that you can use this figure. So if you are doing things manually, so definitely you will have first you can say this is the quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant. So you will divide these in 4 quadrants, and then you will write over here y bar. So at this point you will write down the y bar value or average for y bar, and this will be x1 bar. So how will you find out x1 bar and y1 bar? Basically, you have this series. So you will simply add these values, divide with the total number of observations. In this case, that are 30 total. So add these values, divide by 30, you will have certain value that will be written here, over here at this point. That is the average y bar. Similarly, when you will add x1 values, add all these values, divide by 30, you will have x1 bar. So that x1 bar will be written over here. Okay, and then you will start putting the uh, dots. How will you put dot? Definitely you will first of all scale this x1, you will scale it. The value start from, let us say, 0. Okay, so 0, and the maximum value in the in this series is, let us say, I don't know what is the maximum value, but let us say it is 130, or you can take it as up to 150. Okay, so 150. So you can give difference of 10, 20, or whatever you wanna give the difference according to the space available. Similarly, for y series, you will write down the y values. So let us see what is the maximum value in that case. These are the larger values. So you can start from 0 and you may end up at 3000. So in that case, you will give here the final value as 3000. So you may give the difference of, let us say, 100 or 200 or 300 or even 500. So then you will put substitution. Then what is the value against first value? Let us say the value against first is against 1769, x1 is 93. So 93 will be somewhere over here, let us say, and 176, the other value is there. So like you are going to put some dot over here. So in this way, you will see that in which quadrant there is more, or in which 2 quadrants more dots are there. So let us say we put the dots, and the more dots were there in the first quadrant and in the third quadrant. Then you will draw this line, and this line will be positively sloped. So you will say that there is a positive relationship between x1 and y. Okay, so we have already explained this concept in detail, but as we are taking help of the Excel, so Excel may give it straightforwardly how we can have the relationship using the how can we know the relationship between x1 and y using scattergram, or we also call that scatter diagram. So let us see. For this, you will come over here in data, data analysis, and you will press correlation, then press OK. This window will be there, and then you would have to give the input range. The input range is this. You are interested in these two. Okay. And labels are there in the first row. Okay. Output range. Where you want to give the output range? I want to give it, let us say, over here. Right. So output range is there. Labels are there in the first row. Columns. Everything is fine. So press OK. You will have this. So now you can see basically what is this? This is our correlation coefficient R that we found using some formula in face-to-face class. So this is R and this is 0.5. Okay, so you can say that there is a moderate positive relationship between these two. Okay, so this is the correlation coefficient, explains that what relationship is there in between x1 and x2. Similarly, if you are interested in knowing the relationship between y and x2, you could also find out the correlation between these two. Similarly for other two. Okay, so in this way you will find out the relationship between these two. Okay, so linearity is there or not? You can see it is 0.5096. Positive relationship is there, but how will we know that there is a linearity? For that, we would have to have the graph. Okay. See this graph. Can you see it? So now if you have this graph, see this graph.
सर इसका साइज थोड़ा बड़ा कर दें.
Okay. I think this is the appropriate size now. Oh, this is so big. So at 50% it is. See, you can see, right?
Yes sir.
See, there is some positive. It looks that there is some positive relationship. Okay, so let us say somebody is going to fit the line like this. Okay, so this would be the best fitted line if it meets all the requirements that are there in case of Gauss-Markov theorem. Okay, blue properties. So let us say this is the best sample regression line that we obtained using the OLS technique. Okay. So Samyuddin, can you see this? There is a positive relationship, but there is a weak positive relationship. Okay. Linearity is there,
Yes.
but better would be if we use some other form of the, you can say, independent variable, so that we may have some better answer. So for that, we normally convert the series by taking log. Okay, so let us see what happens if I take log.
सर यहाँ पे कैसी वीक है ये linearity वीक कैसी?
Linearity is weak because the points are spread in such a way that
जी सर.
if I am going to draw a line like this, it is quite possible that you come over here, over there, and you understand that there is a line. There should be line like this. Okay. So again, you can see that this line is also in between the dots. This line that is not linear, that is also there in between the. So
Yes, sir.
these dots are scattered in such a way that anybody can make his own guess. Okay, somebody may say that it is like it goes up, and then from this point it goes down. Okay, so it's upon the observer that how he will draw the line. So at least it is not exactly linear. Okay, the concentration is there, and then dots move like this. Okay, so it is not that much linear. You can say linearity is not there as it should be. Fine. So how we get better result? How could we get better result? You can take the logarithm of the first value. So you can write down here ln of x1. Sorry. You can also take log or ln natural log. It's upon you. Both will resolve the issue. Let me write down it as x1. Sorry. This is x1. Sorry, what is this? I will write down something here. So as the screen is sensitive. Okay. So how will you take log of this? So you can write down here equal to ln and write down this value. Press enter. Now drag down. So see these values. These are the two values. Okay. Now Control C, and here you have to paste the sorry. Here you have to paste the values for ln. Okay. So now if you find out the correlation between these two, or correlation coefficient, let us see what will be the correlation coefficient. Data analysis correlation. Okay, between these two. Okay, output range you may go over here. Let us say you want the results over here. See, it is 0.52217, slightly better than the previous result. In the previous case, it was 0.50. Okay, so now let us have the graph for this.
सर ये जो हमने लॉग ले लिया तो उसमें क्या चेंजेस ले हैं कि वो भी कोलिनियरिटी बढ़ गई है?
Let us see. Let us see. So this is the result when we took the log. Okay, log of x1. This is the result. So here, if you see, basically these values should be on the vertical axis, because this is the dependent variable and this is the independent variable. So how can we change it?
सर पहले हमने सिंपल किया था फिर नेचुरल लॉग लेके किया है, तो इसमें फर्क
Yes.
क्या पड़ा है?
So you can see that in this case there is more positive trend, you can see. Okay, so वो तो हमें वहां से पता चल गया कि 0.50 उस केस में आया, इसमें 0.52 आया, ठीक है ना। लेकिन यहाँ पे अगर आप देखें तो ये कंपैरेटिवली बेटर रिजल्ट्स हैं उसकी निस्बत, ठीक है जी। यहाँ से ये लिनियरिटी कम से कम उससे कुछ बेहतर यहाँ आपको पता चल रही है। ओके, again basically the issue is this, that the relationship is not strong. Relationship is not that much strong, because as it was near 1 it was more strong, but as it is 0.5, so relationship is not that strong. So there is no basically clear cut trend between these two. So for that you have to see that whether this relationship hold in case of population or not. So it is quite possible that it does not hold, it may be hold. Okay, so but from here you can simply say that there is some relationship that is positive, but whether it is linear or not, so for that you can say if you take log, so it becomes slightly more linear as compared to the previous case, but not exactly linear. So for that you have to definitely draw here the quadrants, and then from quadrants you can see that whether it is positive or negative, but it is positive as we see over here. But better would be if you draw the quadrants and then you see that what actually the sample regression line will be. Okay, so बहरहाल इसमें ये है कि linearity का issue जो है that should not be there. Linearity must hold if you want to have better estimators. Okay, then the other is using residual plots. We can also confirm the
Excuse me, sir.
linearity. Yes.
मेरा क्वेश्चन है कि ये जो हमने लॉग लिए तो इसने कैसे इसके लिनियरिटी बढ़ा दी, और दूसरा क्वेश्चन ये है कि जो हम इस तरह खेलते हैं डेटा के साथ, तो इसके जो इन्फ्रेंसेस हम ड्रा करेंगे तो क्या वो वैलिड होंगे इस तरह की?
Yes, so finally basically see, we don't play with the data. In fact, if we are going to take log, okay, so finally when we will have the final results, we will have to take anti-log. Okay, why we take log? Basically, if you see the original data, come over here, see services are in months, fine. Age is in years, fine. So the different, you can say, units are there. So what is the benefit of taking log? The benefit of taking log is that we make the series unit free. If you want to make the series unit free, better would be if you take log of that series. Okay, otherwise if you are definitely in this case you see the linearity issue is there. So you can take square of this series. Let us say if you take square of x1, so as in this case you took log. So if you take log, basically what log how log helps, it makes the series unit free. Okay, But let us say you are interested in you are not clear about linearity, and you see that this is the series where x square is there, where you can say x1 square means x square. X square means now you are going to take the values in square form. Okay. So अब आपकी equation क्या बनेगी? Now your equation will be like this: y is equal to alpha plus beta 1 hat, definitely hats are there, and it is x1 but square is there. Fine. So OLS estimators are fine. There's no problem with the OLS estimates if the estimators are linear. देखिए ना, देर इज नो स्केयर ऑन बीटा, बीटा के ऊपर तो कोई स्केयर नहीं है ना, तो इसके ऊपर अगर स्केयर आ जाता है, या आप इसका लॉग ले लेते हो, या इसको डिवाइड कर देते हो किसी चीज से इसकी रियल टर्म में लेने के लिए, इफ यू वांट हैव द रियल वैल्यू फॉर दिस टर्म, यू कैन आल्सो डू, you can take square of this, you can take cube of this. Okay, so you can give different forms. So in this case I'm going to give it exponential form, so it is quite possible that this is an exponential function. So let
सर
us
यहाँ मेरा क्वेश्चन है, हम जो सीरीज की या तो log लेते हैं या स्क्वायर लेते हैं या जो भी है उसके साथ जो ट्रीटमेंट करते हैं, तो क्या
Yes.
इसके पैरामीटर्स पे फर्क नहीं पड़ता स्लोप पे?
नहीं, पैरामीटर्स पे फर्क नहीं आएगा, पैरामीटर्स
सर
पे
ये
फर्क
नहीं, तो पैरामीटर इसका जो स्लोप है ये सीरीज के साथ इंटर डिपेंडेंट नहीं?
नहीं 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 नहीं, ये इस पे इसको कोई फर्क नहीं पड़ेगा. बीटा 1 विल बी सेम. ओके, इट विल नॉट चेंज.
सर एक दूसरे के साथ प्रोडक्ट में है तो कोई फर्क नहीं पड़ेगा?
नहीं, दैट इज द इंटर वो तो फिर एक अलग चीज हो जाएगी ना. अगर आप देखें इंटरेक्शन टर्म अगर आप इसमें डाल देते हो, y हैट इज इक्वल टू अल्फा हैट प्लस बीटा 1 x1 प्लस बीटा 2 x2, एंड देन देयर इज एन इंटरेक्शन टर्म. वो पूरा एक टॉपिक है, वो मैं आपको बाद में पढ़ाऊंगा, x1 x2. ओके, सो इंटरेक्शन टर्म जो है उसका दैट विल हैव सम एडिशनल इफेक्ट, सम सेपरेट इफेक्ट. ओके, that is there, but we basically are interested in knowing that or saying that the betas are
मतलब
linear.
बीटा सर ये कांस्टेंट है?
ये कांस्टेंट तो है, betas are linear. देखे ना, यहाँ पे बीटा 1 हैट है, ये बीटा 2, ये मल्टीप्लाई हो गया, लेकिन बीटा 3 तो लीनियर है ना. सो इफ यू सी द फर्स्ट इक्वेशन, बीटा 1 इज लीनियर, बट इफ यू सी x1 स्क्वायर, सो दिस इज नॉट लीनियर. x2 is not linear, but it will not affect the authenticity of the beta 1, or the you can say the strength of beta 1 will remain same. वो जो वैल्यू उसकी आएगी वो ठीक रहेगी. हाँ, if beta 1 square is there, then there will be problem, then OL estimate will not be true. Okay, so equation should be,
है भी नहीं ना सर?
the assumption is this, that the assumption is this, that the equation should be linear in parameters, not in you can say the explanation.
ये सेकंड assumption है.
जी, ये assumption मैंने OLS की आपको शुरू में पढ़ाई थी ना.
जी सर, ये तो हम पढ़ चुके हैं सर.
हाँ, लिनियरिटी की, तो वो assumption है. x1 की आप log भी ले सकते हैं, इसका स्क्वायर, इसका क्यूब, इसकी जो मर्जी पावर लें, लेकिन इसको लीनियर होना चाहिए. इफ यू वांट टू हैव द blue estimators, that's linear unbiased estimators. Fine. So let us say if you are going to take care of this, then see what happens, equal to this value and then takes care of this. So ये फिर आप मुख्तलिफ इसको चेक करते चले जाते हैं कि कहाँ जाके ये, यानी ये पॉसिबल है कि इसका रिजल्ट ज़्यादा बेहतर आ जाए. So these are the values. So now if we are going to see the graph for these two, let us see what happens. Where was that scare? Okay, so now data analysis. Yes, correlation coefficient we are interested to know. Okay, tables are there. Output range I'm going to give over here. Okay, see, the relationship is further weak. The relationship is further weak. So now if we are going to have its graph, how will you have its graph? See, so this curve will be like this, you can say. देखें ये ऑलमोस्ट फिर उसी तरह ही ग्राफ आ रहा है। स्केयर लिया ना आपने, देखें जरा इसको देखें ऑलमोस्ट सेम, देख लें। तो वो समीउद्दीन भाई, उसको आप बेशक स्केयर लें, जो मर्जी लें, कुछ ज्यादा फर्क उसमें नहीं पड़ेगा रिलेशनशिप में, ठीक है ना। बस यहाँ से आप ये देख रहे हैं कि ये जो है कंपैरेटिवली कुछ थोड़ा सा उससे अब आप बेहतर कुछ पॉइंट्स बन गए, आप कह सकते हैं यार लिनियरिटी है यहाँ पे, ठीक है जी।
ये सर अब कुछ हाफ में आ रही है उसके।
हाँ, कुछ बेहतर हो गया ना, तो मतलब एग्जैक्ट फॉर्म उसकी क्या है, व्हाट इज द फंक्शनल फॉर्म ऑफ द मॉडल, तो वो एग्जैक्ट करने के लिए फिर हो सकता है आपको डिफरेंट फॉर्म्स चेक करनी पड़े। जैसे मैंने स्केयर लेके किया, हो सकता है आप क्यूब लेके करें तो कुछ मजीद बेहतर हो जाए। हो सकता है आप इसको डिवाइड कर दें किसी
और कितने ट्रीटमेंट्स है सर इसके?
जी,
एक तो स्क्वायर है, एक तो लॉग है, और
हाँ,
कितने?
एक्सपोनेंशियल फॉर्म है, ई की पावर लेके इसको कर सकते हैं, डिफरेंट फॉर्म्स हैं, देयर आर सो मेनी फॉर्म्स। ओके, सो
हाईलाइट तो नहीं है
देन
सर
हाँ,
सर ये एक बिल्कुल रस्सा क्वेश्चन है, मतलब ये कि हमने खामखा इसको क्यों लीनियर बना रहे, इतने ट्रीटमेंट्स कर रहे हैं इसके
हाँ, नहीं वो लेटर ऑन देखिए ना, जब ये चीजें यानी ये सारी प्रॉपर्टीज अभी हम कहते हैं होल्ड कर रही हैं, बट इफ वी विल डिस्कस ऑल दो सिचुएशंस वेयर दीज विल नॉट होल्ड वन बाय वन, हम वो सारी देखेंगे। तो हम इनको वन बाय वन रिलैक्स करते जाएंगे कि भाई लिनियरिटी नहीं है, अब क्या करें, दूसरा उसको कैसे उसको बेहतर करें, राइट। और इस तरह जितने भी इश्यूज हैं जो हमारी असम्पशंस हैं, वो वन बाय वन वी विल रिलैक्स, लेट अस से कांस्टेंट वेरिएशन इज नॉट देयर ओवर टाइम, तो फिर उसको कैसे रिड्रेस करें, ठीक है जी। इफ मल्टीकलिनियरिटी इशू इज देयर, द इंडिपेंडेंट वेरिएबल्स आर बीइंग रिलेटेड विद ईच अदर, सो हाउ वी विल गेट रिड ऑफ दैट सिचुएशन, वो वन बाय वन उसको रिमूव करते जाएंगे। अभी सिर्फ ये आपको बता रहा हूँ कि लिनियरिटी होनी चाहिए, और वो लिनियरिटी आपको कैसे पता चल सकती है। यहाँ पे आप देखें ना, लिनियरिटी है, लेकिन यू कैन से वीक लिनियरिटी, somebody may draw the line in his own way like this, so we are not confirmed. Okay, so if we are not confirmed, we can't say that whatever we have in form of the results, that there is some relationship between x1 and the y. So that is, we have also confirmed that that is true in case of population also. But whether the estimators are efficient or not, they are unbiased or not, so for that we have to take several things into our account. Okay, so let us say we are talking about linearity here. So what is the other way to find out the linearity? Okay, one way is this, that you simply draw the scattergram. Okay, so from scattergram you can see that there is a positive relationship, but there is not a strong positive relationship. Okay, so one thing is this. The other is using residual plots to confirm the linearity of the multiple regression equation. So how you can find out that? Residuals normally plotted on the vertical axis, and y hat is normally plotted on the horizontal axis. So let us try solving that. So if you come over here, where we found the residuals. Okay, so now we are going to take into our account these two, y hat and e. So we are interested to know the relationship between these two. Okay, how will we find? You know, e is equal to y minus y hat. So the relationship between these two, let us see what is the relationship using graph. So graph these two. See this chart. See this chart. This 0 is the mean value, okay? Or if you see the other values that goes up to 2500, what is this? This is the y hat. Okay, so y hat value is this. Let me copy this graph on the whiteboard.
सर एक्स एक्सिस पे क्या है हमारे पास?
देखिए मैं आपको समझाता हूँ. Is it visible? Okay. So on x-axis we have y hat, fine. And what is there on the y-axis or vertical axis? There is e. E are the residuals, and you know sum of residuals is also is always equal to 0. So you can see this 0 over there. 0 is there, fine. So it means that positive values and the negative values of the residuals will cancel out each other, and you will be at this situation over here. Okay. So now, if you see this, what is this graph? Random distribution of residuals is there, randomly distributed or not?
Yes, sir.
जी सर,
There
यस
is no clear-cut pattern. Sometimes goes up, sometime goes down of the central line or mean value. Okay. What is this 0? This is the average of the residuals, mean central value, where it is equal to 0. We have proved that summation is equal to 0. Okay. If you recall your memory in the
Yes,
class.
sir.
Okay. So
Yes, sir.
you know 0. It is that 0. So there is no clear-cut trend. Okay. So if plot shows the random distribution of residuals, there is no clear-cut pattern. Okay. Then model is considered as linear. ठीक है जी समीउद्दीन भाई, आपका मसला हल हो गया. रेजिड्यूल्स कितने काम की चीज है. देखें, इफ देयर वाज सम क्लियर कट ट्रेंड, ओके, तो फिर हमने कहना था कि मॉडल लीनियर नहीं है. यानी if the situation that you have more values here, okay, and then you have more values here under the curve, under the line, the mean value, okay, तो फिर आपने कहना था कि there is a linearity issue. Linearity issue is there. But if there is no clear cut trend, then you will say that linearity is there in the model. Model is linear. Model is linear. बात समझ आ रही है? तो ये आपको वो पहले
रेजिडुअल वाला दोबारा जरा समझाइए सर इसको. ये बहुत अहम है मेरे ख्याल में. दो तो हमारे कामयाब नहीं रही, दो तजर्बे.
रेजिड्यूल्स तो आपका बहुत ही अहम है, बिकॉज यू वुड टेक हेल्प ऑफ दिस इन सेवरल सिचुएशंस.
सर इसको जरा एक्सप्लेन करें इसमें दोबारा. सॉरी सर.
ये वही है ना जो मैंने भी एक्सप्लेन किया है जी, कि मैंने ये देखिए ना, सबसे पहले एक्सेल में मैंने फाइंड किया. देखिए मैंने एक तो आपको एक्सेल ने खुद दे दी ना रेजिड्यूल्स की वैल्यू, पूरा प्लॉट आपको उठा के दे दिया. ये जो सबसे पहले मैंने किया था, इफ यू सी दिस, देखें ये वैल्यूज आपको रेजिड्यूल की उसने उठा के दे दी सारी. ये दीज आर द रेजिड्यूल्स, एंड सेम रेजिड्यूल्स आई फाउंड ओवर हियर इन दिस शीट. ये देखें, यूजिंग फार्मूला एज यू विल डू इन द एग्जामिनेशन और ऑन योर नोटबुक. ये वैल्यूज मैंने निकाली. अब मैंने इन दोनों का आपस में रिलेशनशिप देखा है. ओके, E is on the vertical axis, y hat is on the horizontal axis. जब मैंने इनका ग्राफ ड्रा किया तो क्या सूरत निकली? ये सूरत निकली. इट मींस दैट द रेजिड्यूल्स आर रैंडम. ठीक है जी. और इधर से आप देखें तो ये प्रिडिक्टेड वैल्यूज भी रैंडम है. अगर ये रैंडम है तो ये प्रिडिक्टेड वैल्यूज भी रैंडम है. तो या ये रैंडम हो जाए, या यानी इफ y hat is random or E is random, you will say that there is linearity in the model. Linearity holds. फाइन। और अगर कोई क्लियर कट पैटर्न आ जाए, फॉर एग्जांपल if you have the values like this, let us say you have the values like this, more values are there, dots are there, okay, and then some dots are there. So this is the clear cut pattern. Okay. Okay, initially the predicted values was above the line and then they became below the line. Okay, so in this case linearity issue will be there in the model. So you will see for other situations, you may take log, you may take you can say square, you may take exponential form, x power 3 4 5 6 like that, or you may take the real values by converting the nominal values into real values. So there may be several situations. So but those all will be in that case if this is the situation. If this is the situation, then there is no need to change the explanatory variable. Fine. Explanatory variables are basically fine. The model is linear in parameters, no problem. Okay. पैरामीटर्स में नॉर्मल है, उसको छेड़ने की जरूरत नहीं है। ये हो गई एक बात। दूसरी assumption क्या थी? दूसरी assumption, the second assumption is the variation in the residuals is the same for both large and small values of y hat. So you can write it down if you have.
अनीस भाई ये माइक मेरे ख्याल में ऑफ करें, सिग्नल का मसला बन रहा है।
So once you have confirmed that the linearity is there in the parameters, then there is no problem. The parameters or the estimators will be fine, no problem. Then the second assumption was, write down, let us say, the variation, you can write down, the variation in the residuals is the same for both large and small values of y hat. The variation in the residuals is same for both large and small values of y hat. This was the
सर इसमें मेरा क्वेश्चन
let me explain first. This was the second assumption in the multiple regression analysis. The variation in the residual, see the variation, this is the variation in the residual is same for both large and small values of y hat. So if you see the graph, it starts from 0, goes up to 2500. Okay, so let us say this is 1500, and at 1500 the residual value is this, and then slightly above at 1600 it comes down, and if you see the values other than this going right side, going towards right, definitely there is 2000. So at 2000 the value is this, then at 2100 values it only come down. So random variation is there. Okay, so the variation in the residuals is same in is random in this case, whether the value for y hat is large or small. Okay, so if this is the situation, it means that where the estimators, whatever we will find out, that will be trustworthy. We can trust on those estimators. So this is the second. Yes, Samyuddin. Yes, brother.
माय क्वेश्चन है, ये जो रेजिडुअल्स हैं सर, इसके जो प्लॉटिंग है ये रैंडम मैक्स नो मैटर, इसलिए कि इसका जो रिजल्टेंट इफेक्ट है वो जीरो है। इसका रिजल्टेंट इफेक्ट मतलब उसके सम ऑफ द रेजिडुअल्स आर जीरो, देन
Yes.
देयर रैंडम प्लॉटिंग makes no matter as far.
No. So that is required basically. That should be zero. Their sum effect should equal to zero. If that is not equal to zero, then there will be problem. So we have to see the trend. Let us say you confront with the situation where the trend is like this. So you are going to draw the let us say this is the trend. Then what will you say? More values are positive. It is quite possible. Okay.
Yes sir.
So in this case, you will say that no, linearity is not there in the model. First of all, you will say that linearity is not there in the model. So you have to refine your model. Okay. So model is misspecified.
सर इसका
Okay.
मतलब ये है कि जहाँ पे रिलेशनशिप लीनियर होगी वहाँ पे रेजिडुअल्स के जो सम ऑफ द रेजिडुअल्स हैं वो जीरो होगी
और वो रैंडम होंगे, वो आपको नजर भी आएंगे, यानी कि वो
रैंडम भी होंगे, सम
हाँ,
भी जीरो होगा।
यानी कि उनकी मूवमेंट इस तरह होगी, कभी ऊपर चले जाएंगे, कभी नीचे, कभी ऊपर, कभी नीचे, लाइक दिस। फाइन।
जी
सो दे
सर।
विल रिमेन जस्ट अराउंड द मीन पोजीशन, मीन लाइन।
जी सर।
और अगर वो ये सिचुएशन हो जाती है कि यहाँ से शुरू और फिर ऊपर ही चले गए, तो फिर देर आर सो मेनी इश्यूज, फिर आपके वो एस्टिमेटर्स ट्रस्टवर्दी नहीं रहेंगे। So, for example, in this case, as I'm taking into my account the second assumption, the variation in the residuals is the same for both large and small values of y hat. So we can take example that let us say, we are talking about income of the people who are above 50 years. Okay. And we want to compare that with the income of the people who are, let us say, above 30 years or around 30 years or exactly 30 years of age. And you can take the people who are exactly 50 years of age. So it is quite possible that you confront with the situation where the random variables, definitely you will have data for both. So there will be two series. Okay. So you are talking about, let us say, this is the situation. Y is equal to alpha plus beta x plus beta x. So this is 1, this is 2, 2, 1, hat, I, hat. Fine. So let us say x1 is the age of the people, let us say 50 years. ये 50 years के लोग हैं or around 50 years. So what is their income, let us say? ठीक है जी, वो if you are going to, let us say, their income on y hat is basically the salary. So you may take the another example where you may take x1 as the service length. So service length of I'm going to rephrase my question. Sorry. Y bar is the salary. X1 is the, you can say, experience. In service, experience of 50 years old employees. So it is quite possible that there is a person in the firm who is of age 50 years, but he has lesser experience as compared to the other person who is there in the firm and with the 30 years of age, but he was inducted at some initial age and he has many years of experience. So it may differ. So you can take different cases. So experience of 30 years old employees. So in this, let us say this is the situation. Then what will happen? It is quite possible that the estimated value, this is the y hat, here it is E, okay, and if you scale it, estimated values of salary, let us say, goes up to 5,000. Okay. So the people who are with the age 50 years of, who are 50 years old, they have salary over here. Okay. And the 30 years age, the residuals for them are like this. So this may be the situation that you have this situation. So what this means, there is no random variation. There is no random variation. There is no random variation in the residuals. ठीक हो गया? पहले वो सारों के लिए एक खास क्लास के लिए वो इस रेंज में है, उसके बाद एक खास कुछ खास लोगों के लिए वो इधर चले गए, तो रैंडम वेरिएशन तो ना हुई ना
जी सर।
इफ रैंडम वेरिएशन नहीं है उधर, तो देन you will see for some other, you will you can say modify your model, you will have to modify your model. Linearity will not be there. ठीक है जी?
ये सर लीनियर भी नहीं होगा
जी,
लीनियर भी नहीं होगा क्योंकि मीन के पास
वही ना, लीनियर नहीं होगा ना जी, लीनियर नहीं होगा। लीनियरिटी का इशू आपको बता दिया रेसिडुअल्स ने। ठीक है
यस सर।
तो ये थी दूसरी।
सर मतलब हम जो नेचुरल लॉग ले रहे थे या स्केयर ले रहे थे, उससे अच्छा है कि हम सिर्फ ये रेजिडुअल ले लें।
जी जी, रेसिडुअल्स आप जब लेंगे ना तो ये आपके बहुत से इश्यूज को रिजॉल्व करेगा। अच्छा,
वो तो ऑलरेडी हमने ले लिया ना सर, y माइनस वाई बार।
हाँ जी, हाँ जी, आप यही कह रहे हैं ना रेसिडुअल, तो रेसिडुअल तो आपको लेना है ना जी, क्योंकि रेसिडुअल लेंगे तो आपके अगले मामला हल होंगे।
ठीक है
ठीक
सर।
है, ओके।
ये रेजिडुअल्स वाला इंटरप्रिटेशन भी आसान है सर।
जी
मतलब
बहुत आसान, बहुत आसान। ओके, so now I have to rub a few things.
एक्सक्यूज मी सर।
Yes boy.
सर थोड़ी देर के लिए ब्रेक ले लें, काफी टाइम हो।
मेरा ख्याल है बस इसको थोड़ा पहले खत्म कर देंगे, इस चीज को, बस ये असम्पशंस हैं, इसको खत्म हो लेने दें, फिर उसके बाद ब्रेक ले लें।
ठीक है सर, ठीक है सर, नो प्रॉब्लम।
जी, अच्छा, तो इसमें जो है ना आगे आप देखिए, the variation around the regression equation is same for all the values of independent variables. वही बात जो मैंने की आपसे, if variation is same in the residuals, ठीक है, for all the independent variables, then what will you say? You will say that there is no issue of heteroscedasticity. Homoscedasticity is there. So as the same graph is helping us in finding the linearity, the same graph is also helping us in knowing that whether there is any issue of heteroscedasticity or not. So if you see the present case that we have over here in this graph, yes, this graph, see this graph, there is no clear-cut pattern. So one thing is this, that linearity is there in the model, and the other information is this, that there is no issue of heteroscedasticity. Okay, there is no issue of heteroscedasticity. The assumption of homoscedasticity holds. The assumption of homoscedasticity holds.
एक्सक्यूज मी,
Yes.
अगर हेट्रोस्केडास्टिसिटी का मसला होता, इशू होता, तो फिर ये जो इसकी प्लॉटिंग है कैसे होती रेजिडुअल्स की?
का कोई उसका ये रैंडम ना होती।
अच्छा,
ये
ठीक है
रैंडम
सर।
ना होती, यानी कि वो जैसे मैंने नेक्स्ट बयान किया ना, देखें यहाँ ये
यस सर, यस।
हाँ, इस तरह का इशू आना था कि उसमें रैंडम नहीं होना था। अभी तो ये है ना कि ये रैंडम है,
जी सर,
एकदम वैल्यू ऊपर है, फिर लाइन से नीचे चली गई, एवरेज से फिर ऊपर चली गई नीचे, सो द वैल्यूज आर रैंडम.
थैंक
So
यू
this
सर।
graph is helping us to know that the model is linear and there is no issue of heteroscedasticity. In fact, the assumption of homoscedasticity holds. The assumption of homoscedasticity holds. So ये both जो है ना, you know that both these things are clear from this one graph. Okay.
सर, हाउ टू रिमूव द हेट्रोस्केडास्टिसिटी, इसके फिर अलग ट्रीटमेंट हो?
उसके लिए फिर बहुत से
अलग
टेस्ट है, वो पूरा एक टॉपिक है, वो पूरा एक टॉपिक है, इंशाल्लाह अपकमिंग क्लासेस में हम उसको डिस्कस करेंगे, उसके लिए बहुत से टेस्ट हैं। ठीक है जी,
जी सर, जी सर।
तो वो टेस्ट हम जब लगाएंगे तो वो फिर उसमें रिमूव हो जाएगी। ठीक है जी, अच्छा जी, अगली बात क्या है जी? अगली assumption है the independent variables should not be correlated. The independent variables should not be correlated. ये क्या है जिसको हम क्या कहते हैं? We call it multicollinearity. Multicollinearity, ठीक है। और मल्टीकॉलिनियरिटी की हल्की सी बात करके फिर हम इसको प्रूव करने की भी कोशिश करते हैं कि हाउ द एस्टिमेटर्स गेट डिस्टर्ब इफ द मल्टीकॉलिनियरिटी इशू इज देयर। Okay, so what we mean by multicollinearity? Let us say this is your model. This is 2, that is there 1, 1, that is there 2, I, that is there, fine. So the assumption is this, that x1 and x2 must not correlate. X1 and x2 must not correlate. If they will correlate with each other, or if there will be some relationship between x1 and x2, then the estimators will not be trustworthy. You cannot trust those estimators that you have found after the hectic exercise that you performed. Okay. So how will you check that there is some relationship between x1 and x2? Simply you can use the scattergram, or otherwise you can regress one on the other. Okay. So let us try knowing this. How will we get rid of this, and how will we know that there is some issue of multicollinearity? Okay, so the rule is this, that if you find out the correlation coefficient, and that is in between minus 0.70 and plus 0.70. You know how can you find out the correlation coefficient? There are two
यस
variables.
सर फार्मूलाज का
One is x1, one is x2. Okay, so एक को आप डिपेंडेंट बना लो, एक को इंडिपेंडेंट बना लो। ठीक है जी, मेरी बात समझ रहे हैं ना? Let us say you are going to regress x1 on alpha plus beta x2. ये आपने regression की, तो आपको regression का you will be able to find out the correlation coefficient. Okay, so if correlation coefficient is in between 0.70 minus 0.70 and positive 0.70, then you will, what will you say? You will say that the multicollinearity issue is not that much severe. Okay, so we can take the we can retain the explanatory variables in the model. There is no problem, right? Otherwise, if it exceeds 0.70,
सर इस पॉइंट को दोबारा जरा एक्सप्लेन करें। ये -0.70
देखिए कोरिलेशन कोएफिशिएंट जो है वो आपको पता है कि -1 से +1 तक वेरी करता है। कोरिलेशन कोएफिशिएंट, फर्स्ट लेक्चर, recall that lecture.
ठीक है सर।
Where we proved that this is the correlation coefficient. We proved the formula, and then we found different values in different situations. Okay, so correlation coefficient may be -1, or at maximum it may be 1. Okay, so if the correlation coefficient of you can say the explanatory variables that you are going to take into your account is in between minus 0.70 and positive 0.70, then you will say that although there is some issue of multicollinearity in the model, these two explanatory variables are correlated with each other, but we can retain both these at the same time in the model, because the severity level is not that high that we drop one out of these two, right? देखें there may be several situations. Let us say I'm going to give, being the, you can say, admission committee member, I'm going to see that whether I will take into my account the CGPA of the students or the percentage marks of the students. Okay. So in that case, if you see, let us say I'm going to give these are the number of students that obtained, you can say, admission in the previous semester. Okay, X1 is there, representing the percentage marks of those students, and X2 is representing the CGPA of those students. This may be the situation. So if you see that CGPA and the percentage marks are correlated, and their correlation coefficient is so high that it is just near to 1, okay, then you may drop one out of these two. You can only consider the percentage marks, or you can only consider the CGPA to give admission to the upcoming students. Okay. So कहने का मकसद ये कि इन दोनों को आपस में कोरिलेट नहीं करना चाहिए, but in fact in reality they correlate. They always correlate up to some extent. So we have simply defined that we will be ready to bear the issue of multicollinearity if the correlation coefficient will be in between this range. Okay. So
सर
one
हमने
way,
रेंज चेंज की है इसकी
नहीं,
सर
0.70,
1 से -1 होती है ना, तो यहाँ पे 0.70 आपने लिखी है।
no, -1 to 1, वो जो आप कह रहे हो ना, वो तो आर स्क्वायर है ना जी, that is R square, coefficient of determination. This is correlation coefficient. There is no square on this. भूल गए आपने, रिवाइज नहीं किया।
नहीं सर याद है, मैंने कोरिलेशन कोएफिशिएंट की भी किसी जगह
कोरिलेशन
-1
कोएफिशिएंट की वैल्यू नेगेटिव भी तो होती है ना, अगर वो -1 के करीब हो तो वो क्या होगा, स्ट्रांगली नेगेटिवली कोरिलेटेड।
यस सर।
तो नेगेटिव साइन तो होगा ना उसमें। हाँ, जब उसको आप कोरिलेशन कोएफिशिएंट ऑफ डिटरमिनेशन लेंगे, व्हेन यू विल टेक केयर ऑफ दैट, तो फिर वो माइनस वाली साइड खत्म हो जाएगी, फिर 0 to 1 तक जाएगा। नहीं याद है? हाँ। So this is one strategy to know that whether there is a severe problem of multicollinearity or not. The other way that we use
सर इसमें एक क्वेश्चन है।
जी 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 जी,
सॉरी सर।
जी जी,
जो मल्टीकोलिनियरिटी है, इसको खत्म करने के लिए पूरे एक्सप्लेनेटरी वेरिएबल को खत्म करना होगा, या इसमें और इसके ट्रीटमेंट हैं?
इसके ट्रीटमेंट्स ये हैं कि उसको रियल टर्म्स में भी लेके कई दफा हम खत्म कर लेते हैं, कई दफा हम उसको ड्रॉप कर देते हैं। तो अगर वो सीवियर इशू आ जाए तो फिर हम उसको नॉर्मली ड्रॉप कर देते हैं, या हम उसकी फंक्शनल फॉर्म चेंज कर देते हैं, तो उससे भी कई दफा इशू रिजॉल्व हो जाता है। ठीक है जी। तो अगर ये अभी जो दूसरी the second thing that I'm going to explain, that is further easy to understand, and in that case you will be more able to see that whether you have to drop the variable or you don't have to drop the variable. Okay, so ये नॉर्मली ये होता है कि क्योंकि मल्टीकोलिनियरिटी का इशू रहता है वहां पे आपके मॉडल के अंदर, इसको आप बिल्कुल खत्म नहीं कर सकते, कुछ ना कुछ आपस में रिलेशनशिप इंडिपेंडेंट वेरिएबल्स की आपस में होती है। So therefore you simply see that whether this issue is so severe that it will affect the you can say the estimators, or there will be no problem. Okay, so the other way that will help to find out the issue of multicollinearity, or you can say the presence of multicollinearity in the model, the formula is VIL. Let me write down this formula: 1 minus RJ square. What is this? This is the variance inflation factor. So we also use this formula to know that whether the multicollinearity is there in the model or not. Yes, why? जी
सॉरी सर, मैं दोबारा क्वेश्चन पूछना है। सर कोरिलेशन कोएफिशिएंट की -1 से 1 नहीं लिखी हुई है मेरे पास, रेंज उसकी, उसको
दुरुस्त कर लें। -1 से +1 है ना, -1 to
+1।
जी बिल्कुल यही है, आप ठीक कह रहे हैं।
तो सर वो -0.70 से +0.70 वो किस चीज की थी?
नहीं, वो तो हमने एक यानी कि रूल ऑफ थंब बना लिया ना, हमने एक रूल ऑफ थंब बना लिया। हाँ, ये पॉजिटिव 1 है, ये नेगेटिव 1 है, ठीक हो गया। ये तो इसकी रेंज है आर की। और
यस
वो
सर।
जो मैं कह रहा हूँ ना, ये जो मैंने बात बनाई है ना, ये वाली, ये एक रूल
यस
ऑफ
सर।
थंब है कि इफ correlation coefficient is, let us say, it may not exceed, it could not exceed 1. Okay, it could not
यस
be below -1.
यस सर।
R could not be below -1, it could not be -2, it could not be 2. Fine, but it is in between these two. The other point is that I have just explained here. For in the issue of multicollinearity, you can say that this is the rule that we have set, that if our correlation coefficient that we will find is in between these two values, is in between these two values, or even if it is 0.7 inclusive, both are inclusive, 0.7 is there, minus 0.7 is also there,
यस सर।
and all values are there in between these two values. Okay, so this is the rule for only multicollinearity. R will vary from -1 to 1, that is confirmed, there is no question regarding that. But when you are talking about multicollinearity, you will see the correlation coefficient, whether it is in between these two values or not. If it is in between these two values, then you will say that there is no question of multicollinearity. Let us say I have found here the, I recall, yeah, see, it is point, what is this value, what is this value? This is giving you the correlation coefficient.
यस सर।
So it is in between -0.7 and 0.7. Okay, so there is multicollinearity, but that is acceptable, no problem. We can retain these variables there. ठीक हो गया ना?
यस सर।
तो इसी तरह फिर हमने दो वैल्यूज, बेसिकली दिस वाज बिटवीन y and x, but you can for multicollinearity you will take into your account two independent variables into your account. ठीक है ना, वो मैं आपको लेके दिखा देता हूँ, इसमें कोई ऐसा परेशानी वाली बात नहीं है. Let us say we are going to take these two into our account. Okay,
यस सर।
तो इनको आप यहाँ से ये कॉपी कर लें over here. ओके, यहाँ से आप इसकी आपस की कोरिलेशन फाइंड कर लें. हाउ विल यू फाइंड? यू आर इंटरेस्टेड इन फाइंडिंग आउट द कोरिलेशन कोएफिशिएंट. कोरिलेशन, ओके, कहाँ से चाहिए? ये इसके दरमियान चाहिए. दिस इज द रेंज. इट इज फ्रॉम A1 to B31. फाइन, ओके. लेबल्स, आउटपुट रेंज दे दें, आउटपुट रेंज इसको दे दें, वो पहले दे रखी है उसने. फाइन, ओके. It is 0.7755. Okay. It means that it has exceeded 0.7. So
Yes, sir.
multicollinearity issue is there. Multicollinearity issue is there in the model. ठीक है
सर मतलब
तो
हमने
अब
ये रूल
जो है वो एक्चुअली नहीं रहेंगे. क्लियर हो गया? ये एक
Yes,
तरीका है multicollinearity. This is the way how to detect the multicollinearity in the model. Fine.
ठीक है.
अब सर इसके ट्रीटमेंट क्या है इसके? ये जो एक्सप्लेनेटरी वेरिएबल है इसमें से किसी एक को भी ड्रॉप करेंगे? फिर
हाँ,
किसको ड्रॉप करेंगे सर? किसको, कौन से वेरिएबल को ड्रॉप करेंगे?
वो फिर आपको देखना पड़ेगा कि y के साथ किसकी एसोसिएशन स्ट्रांग है. जिसकी ज्यादा
वो
स्ट्रांग
कैसे
है
मालूम
उसको रिटेन
करेंगे?
कर लेंगे,
वो
जिसकी
कैसे
वीक है उसको ड्रॉप कर दें.
सर, वो कैसे मालूम करेंगे?
सर वो भी आपको कोरिलेशन कोएफिशिएंट ही बताएगा ना.
अच्छा,
देखिए ना, इन दिस केस यू हैव रेग्रेस्ड, यू कैन से 1 x1 on x2.
जी
अगर
सर.
यहाँ पे अगर y हो, सी दिस इज द आउटपुट.
तो एक एक एक्सप्लेनेटरी को हम चेक करेंगे.
सी ओवर हियर. See here, this is the multiple R, this is the correlation coefficient in this case. So basically this output is for all explanatory variables, that what is their relationship with the dependent variable, and this is the R scale. So but if you are interested in knowing that which has how much correlation with the dependent variable, then you will check one by one. आपको one by one check करना पड़ेगा. जैसे कि आपने इस केस में, as you have found, XC, this was salary, this was age. So this, I think in this case, I took care of this. There's no need to take care of this. But the question is this, that if you have data like this,
सर मतलब y के कॉलम को साथ रखेंगे और बारी बारी x1 x2
मैं explain कर. Okay, so now see which is strongly related with y. So यहाँ से आप जाएं data analysis में. Correlation. Yes, between these two. Output range दें इसको. .50. ठीक हो गया. आगे आ जाए. Analysis, correlation. Tables are there where you want to have output. You want to have output over here. 0.255. देखें. It means that you may drop age. Samyuddin, brothers, Samyuddin. Out of these two variables,
Yes, sir. Yes, sir.
you may drop age because the relationship of salary or salary and age is very weak. Weak relationship between these two. ठीक है जी. यहाँ से भी ये भी आपको पता चल जाता है. Okay, so now basically I was interested in explaining variance inflation factor. This is variance inflation factor. So for variance inflation factor, you will take into your account the value for variance inflation factor as if it is greater than 10, greater or equal to 10, then there will be a severe problem of multicollinearity. Then there will be a severe problem of multicollinearity. Otherwise not. Otherwise not. So otherwise you will retain the variables. But if you see that the VIF exceeds 10, then you will have to consider the multicollinearity issue. You will have to take this issue into your account. You can say.
सर इसका सॉरी सर, इसका मतलब ये है कि मुख्तलिफ डेटा के लिए मुख्तलिफ ये मल्टीकोलिनिटी की पैरामीटर्स होंगे.
जी जी बिल्कुल बिल्कुल. लेट अस से
मतलब इन्फ्लेशन के लिए अलग होगा पैरामीटर है.
अब लेट अस से इसी केस में आप देखिए. देखें आपने यहाँ मैं आपको बताता हूँ कोरिलेशन इन दोनों की कोरिलेशन मैं निकालने लगा. लेट अस से डेटा एनालिसिस कोरिलेशन. ओके, x1 and x2. So I'm going to give the range. Okay. Where I want to have the output, over here. This is the situation. Fine. What is this? This is R. This is R. And if you recall the formula for variance inflation factor, that is 1 divided by 1 minus R square. Okay. So coefficient of determination basically you have to use. So what will be the value for that? Equal to this value, and when you will take care of this, you will have 0.601, this value. Okay, 0.60148. Okay, so now come over here. VIF will equal 1 divided by
1 minus R square
minus
R square.
This value. What is the value?
2.50.
2.50. 2.50. It is less than 10. It is
Less than 10.
less than 10. So see, if you see the first criterion, this criterion, 0.77 is there. So if you depend upon this, you will say that yes, multicollinearity is there, but should we drop the variable or not? So you will say that it is above 7, we should drop. Okay, but the other way or other technique is better to decide before uh, retaining or dropping the variable, to check the VIF, variance inflation factor. If you see this, this is 2.50883, less than 10. So it means that although the multicollinearity issue is there in the model, but it is not
Not
that
severe.
it is not that severe that we drop
Yes.
the age or service from the model. Okay, so better is to depend upon VIF. Better is to depend upon VIF. So ये आपने इसकी वैल्यू आपस 2 आ गई, लिहाजा you are not going to drop the variable, any variable out of these two.
सर हम पिछले 2 केसेस में भी निकाल सकते हैं भाई?
नहीं, देखिए यहाँ पे इस केस में अगर आप देखो तो यहाँ वो आपको बता रहा है कि इट इज रिलेशनशिप इज हैज एक्सीडेड 0.7. ओके, सो इफ यू आर गोइंग टू ड्रॉप वेरिएबल एट दिस स्टेज, दैट वुड नॉट बी फेयर. यू हैव टू चेक और यूज VIF बिफोर टेकिंग एनी डिसीजन. ओके, नॉर्मली आप लोग देखते हो ना सॉफ्टवेयर्स में, eViews वगैरह में, तो वो आपको वहां बता देता है कि VIF की वैल्यू क्या है. VIF की वैल्यू क्या है. So let us try to have this in eViews.
सर इसके एक जो एक्सक्यूज मी सर, ये जो 1 और -1 के दरमियान जो रेंज है, ये और 10, ये दोनों में क्या फर्क है सर? दो स्टैंडर्ड्स आ गए सर, 2 स्टैंडर्ड्स तो आ गए ना सर.
There are two standards.
मल्टीकोलिनियरिटी की 2 स्टैंडर्ड्स हैं.
जी जी जी
एक तो हमने चेक करना है कोएफिशिएंट के साथ, तो एक -1 और 1 के दरमियान है, और ये दूसरा VIF के साथ है जो कि 10 है.
जी 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 जी. तो ये देखें ना, दोनों में फर्क ये है कि जो पहला जो इशू जो मैंने डिस्कस किया, वहां से आपको ये पता चल गया कि उसका सिवियरिटी का लेवल क्या है, इज दैट एक्सेप्टेबल और नॉट. अगर वो 7 से कुछ एक्सीड कर गया तो इसका मतलब है कि यहाँ कुछ प्रॉब्लम बन गई है, लेकिन क्या हमें ड्रॉप कर देना चाहिए या नहीं, वो अभी हम यहाँ इस स्टेज पे कंफर्म नहीं कर रहे. वी विल कंफर्म दैट आफ्टर कंफर्मिंग द वैल्यू फॉर VIF. So the criteria is this, the strategy will be this, that if our VIF will exceed 10, then we'll only drop this, otherwise not. ठीक है ना. तो वो R से हम R जब हमने देखा तो वो slightly that was 0.77, slightly above 0.7, तो उसको देख के स्ट्रेट फॉरवर्ड ड्रॉप नहीं कर देना, बल्कि VIF की वैल्यू लेके कंफर्म कर लेना है कि वेदर इट शुड बी ड्रॉप्ड और नॉट. ठीक हो गया ना. हाँ, VIF की वैल्यू के ऊपर आपने डिपेंड करना है, यानी वो एक स्ट्रेटजी है, लेकिन उस पे उस तरह आपने डिपेंड नहीं करना. तो आपने डिपेंड करना है VIF
ड्रॉप करने के लिए VIF
वैल्यू 10 से ऊपर आए तो 10 से ऊपर आए तो फिर ड्रॉप करना है. 10 से नीचे आए, 9 भी आए तो नहीं करना. ठीक है ना. तो लेट अस sheet 5 and sheet 6. Let us have sheet 6 over here. कहाँ सेव किया था उसने? इकोनोमेट्रिक्स, ये आ गया. ओके,
अच्छा सर, इसमें जो VIF में R स्क्वायर था, ये इसको क्या प्रोनाउंस करते थे हम?
कोएफिशिएंट ऑफ डिटरमिनेशन. coefficient of determination. So all of you familiar with this Eviews?
No, sir. No, sir.
No, sir.
Not at all.
No, sir.
ओके सो चलो कुछ इसको भी देख लेते हैं. Yes, we need sheet 6, so therefore I'm going to give it next. Okay. Yes. Okay. Series 1 and series 2. There are no values over there. In fact, there was no value. I didn't paste the values over here. That is the reason. Okay. I have pasted the values over here. So you can, if you take the value straightforwardly in the views, import the values, so it will import it straightforwardly. Otherwise, you can also have the values over here. Like this, work file. Okay, frequency is annual, no problem. Date issue. Let us say, how many values were there? 30 values. So you may start from 1992. 2020. I think I again didn't give the values. So I will explain it later on because I don't remember.
सर ईवीयू में होता क्या है?
E-view में ये आपको जो है ना उसकी वेरियस इन्फ्लेशन फैक्टर के बारे में बता देगा. Let me try importing this. This is PB. Let me try it again. File. E-views work file. Foreign data as work file. So from here go to desktop. From desktop Econometrics. ये देखें ये अब उसने दे दिया है. ये वैल्यूज आ गई सारी. ओके. नेक्स्ट. 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 फिनिश. ये देखें ये उसने सारी वैल्यूज दे दी. ठीक है. So now you are interested to regress. Let us say, come over here. Estimate equation. You are going to estimate equation. So now you can estimate. How? First of all, you will write down here. The variables are in front of you. Salary. Salary. So salary is there, click over here, salary will be written, salary, then give space, C. C is your intercept. Then you are going to give the other variables. The first variable is service. So service, then give space, write down. The next was age. So write down age.
सर मतलब ये आप इक्वेशन के मैनर में लिख रहे हैं?
हाँ, इक्वेशन मैं इसको E-views को दे रहा हूँ, देखें ये मुझे रिजल्ट्स दे देगा. Age x2, then whatever I have done in Excel, the same I am going to do in the here in E-views. But here in E-views, I'm interested to find out the variance inflation factor. Okay, that I will find out later on. But now, first of all, as you are not familiar with the E-views, so therefore I am writing down the equation first, and I want to have the regression results first for the whole equation. Then I will go to find out the value for variance inflation factor. Okay, so this is my second variable, independent variable. Then there is third variable that was gender. So GEN, gender is there. Double click this, space, and the final was job. And double click this. Fine. Least square sample 1 to 30 observations are there. Press OK. This is the output. This is the output. Okay, so now you can see these estimates, and you can compare these estimates with the Excel output. If you see Excel output, so let me open the Excel file that I've simply closed now. This is your Excel file. This was the summary output. These were the coefficients. If you see, now you can compare these two. See, 651. See these values: 651, 651, 13, 13, minus 6.7. So all values are there. All values are there. Whatever I have found in the Excel, the same values are there in the E-views. Clear? But E-views is giving me some more information. Right? Okay. So in this way, you will find out. In this way, you will find out the output or regression results. Okay. Then if you come over here, press view, and you have to come over here, coefficient diagnostics. See coefficients diagnostics, and come over here. See variance inflation factors are there. Variance inflation factors are there. So the result is there. Everybody can see this. Okay, so centered VIF, centered VIF, centered VIF, you have to take into account these values. See 2.7, 2.5, 1.0, 1.0. So the issue of multicollinearity is although there, but that is not that severe that we drop any variable. ठीक हो गया ना? अगर यहाँ से किसी वेरिएबल का VIF बड़ा हो जाता 10 से, तो then it was recommended that you drop that. Brother Samyuddin, clear?
Yes, sir. Yes, sir. Mashallah.
Okay, so this is the situation that you have to follow. So multicollinearity issue is normally there in the model, but we simply take into account this issue if VIF exceeds 10. Otherwise, it remains there. There is no problem. Right? Finally, the final thing that I want to share with you is that I have to clear the frame, and I am interested in solving one thing. here on the board. What is that? Some theory is there. If you want to see this, it will take a few minutes, almost 10 minutes, and then on completing this, inshallah, this is the last topic that I'm going to do here. It is again regarding multicollinearity, but now what we are going to do, see, yi is equal to beta 1 plus beta 2 x2i you can write down, because or x1i, it's upon you. Okay, if there is some x1 variable, you give the value, you can write down x1. Otherwise, if you are going to take your variable as x2, so write down x2 plus beta 3 x3i plus mu I. This is the model you are familiar with. This is the population regression equation or population regression function. Okay, indeterministic.
Yes, sir.
Okay, so we are saying that in case of multicollinearity, R, I am going to write down R. R is for correlation coefficient. The correlation between here 2i is there, 2i is there, and x3i, these two series are there. These two are independent variables. Okay, so the assumption is there is no perfect multicollinearity. There is no perfect multicollinearity, means the correlation coefficient for x2i and x3i will not exactly equal to 1 or minus 1. Fine. If it is equal to 1 or it is equal to minus 1, then you will say that there is multicollinearity in the model, and we have to consider this, and then VIF and so many other things. But the OLS, you can say, assumption is this, that if you have to have the beta 2 and beta 3 blue best linear unbiased estimators, then this should not be the situation. This should not be the situation that the correlation coefficient between the first explanatory variable and the second explanatory variable is exactly equal to 1 or minus 1. It may be in between. If it is in between minus 1 and 1, okay, no problem. We will see. We can tackle the situation, or multicollinearity is not that severe that we take care of this. Okay, but if it is exactly equal to 1, or if it is exactly equal to minus 1, then the assumption will be relaxed, or it will be failed. Okay, so the
सर अगर 0.9 है,
जी,
अगर 0.9 है तो भी इसको एक्सेप्ट करेंगे.
You will accept the multicollinearity issue as it is, and you will go for VIF.
0.9 जी
You will
सर.
go for VIF. वो है ना उधर VIF. ये तो एक assumption है ना, जिसमें वो कह रहा है कि ये exact सिचुएशन नहीं होगी. अगर exact हो जाती है तो फिर ये दोनों वेरिएबल इस हद तक आपस में कोरिलेट कर रहे हैं कि आप इसमें से एक इस्तेमाल कर सकते हैं.
मतलब 0.9 है तो फिर VIF से हम टेस्ट करना लाजिम होगा.
जी हाँ, अगर वो 0.7 से एक्सीड कर जाता है, वहां से कोरिलेशन कोएफिशिएंट 0.7 से एक्सीड कर जाता है, तो फिर VIF लगा के चेक कर लेंगे क्या इसको ड्रॉप करना है या नहीं करना.
जी सर, जी समझ आ गया.
ठीक हो गया ना. तो बहरहाल ये असम्पशन है कि एग्जैक्टली इक्वल टू 1 नहीं होगा कोरिलेशन कोएफिशिएंट. ठीक है जी. अच्छा, when explanatory variables are perfectly correlated, this is the situation. Fine.
सर एक और एग्जम्पशन है मेरी अपनी. ये जो यहाँ के जो कोएफिशिएंट की जो वैल्यू है 0.7, क्या उसके बराबर है VIF के 7 के बराबर हो सकती है कि नहीं ये वैल्यू?
नहीं, देखिए जो कोरिलेशन कोएफिशिएंट है दैट विल, देखिए वो देखिए जो VIF की वैल्यू है वो तो 10 है, और जो उधर से जो आपकी कोरिलेशन कोएफिशिएंट की वैल्यू आ रही है दैट विल बी इन बिटवीन -1 एंड 1. वो तो 2 नहीं हो सकती ना. और फिर वीआईएफ के फॉर्मूले में आप स्केयर यानी कोएफिशिएंट ऑफ डिटरमिनेशन यूज कर रहे हैं, ये भी देखें ना आप।
मैं
वहां
वैसे
आर
भी एज्यूम कर रहा था सर,
क्या अस्यूम कर रहे थे?
मैं ये एज्यूम कर रहा था कि यहाँ का जो 1 है सर, ये क्वेश्चन के जो वैल्यू है, तो
जी जी
वीआईएफ के 1 के बराबर, लेकिन वो नहीं है। ठीक है सर।
नहीं नहीं, दैट इज नॉट पॉसिबल, एग्जैक्टली नॉट
यस सर,
पॉसिबल।
ये तो 1 और -1 के दरमियान है ना।
देखिए मेरी बात सुने, अगर ये 1 होता है, देखें वीआईएफ है ना, लेट अस से r इज इक्वल टू, लेट अस से r इज इक्वल टू 1, आप कहते हो ये स्मॉल r,
जी
द
सर।
कोरिलेशन कोएफिशिएंट, लेट अस से इट इज इक्वल टू 1, फिर क्या होगा, r स्क्वायर जब आप लोगे तो वो बन जाएगा 1,
हाँ जी।
1 स्क्वायर इज इक्वल टू 1,
0।
तो ये हो जाएगा 1 डिवाइड बाय 0,
यस सर।
क्या हो जाएगा 1 डिवाइड बाय 0, 1 डिवाइड बाय 0 मींस इंफिनिटी, सो
Infinity.
इंफिनिटी इज ग्रेटर देन 10,
यस सर।
तो
Yes,
ऑटोमेटिकली वहां इतनी सीवियर मल्टीकॉलिनियरिटी है कि वो वहां,
यस सर,
मेरी बात
समझ
रहे
आ
हैं ना?
गया, आ गया सर, समझ।
जी 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 जी,
Thank
तो इट शुड बी लेस देन 1, फिर आप चेक करेंगे कि 10 से ऊपर है या नीचे है, 0.9 लेके चेक कर लें, 0.99 लेके चेक कर लें, तो जहां इसकी वैल्यू वीएफ की 10 से एक्सीड कर जाएगी वहां आप वो वेरिएबल कंसिडर करेंगे, देयर इज सीवियर मल्टीकॉलिनियरिटी एंड वन आउट ऑफ दीज टू वी हैव टू ड्रॉप। फिर
बस
उसमें से
मैं भी
फिर
जी।
जिसकी स्ट्रॉन्ग रिलेशनशिप है वाई आई के साथ उसको रिटेन कर लें, जिसकी वीक है उसको ड्रॉप कर दें।
बस मैं वैसे कोई शॉर्टकट ढूंढ रहा था, लेकिन नहीं, तुक्का नहीं लगा। जी सर।
नहीं नहीं, वो these two are separate things।
यस सर, थैंक
अच्छा
यू सर।
यहाँ तक ये आपको बात समझ आ गई, ये बात मैंने एक्स्ट्रा नीचे जो लिख दी इसकी जरूरत नहीं है। मैं नॉर्मली आई वाना show you some theory basically in such a way that you may become able to know the issue of multicollinearity in further detail. Let us say now you are going to regress x2i. Basically you are interested to know the multicollinearity issue. Okay, so let us say x2i is equal to lambda x3i। थोड़ी देर के लिए इंटरसेप्ट को भूल जाएं, अगर डाल भी देंगे तो थोड़ा कॉम्प्लेक्स हो जाएगा, सॉल्व हो जाएगा, लेकिन थोड़ी देर के लिए आप अल्फा को भूल जाएं, ठीक है। देयर इज नो इंटरसेप्ट, ओके, देयर इज नो इंटरसेप्ट, बात जीरो से शुरू हो रही है, बात जीरो से शुरू हो रही है, ओके, इंटरसेप्ट नहीं है फॉर द टाइम बीइंग, जस्ट कंसीडर इट। Now you are going to see this situation where x2i is equal to lambda x3i. It means that there is relationship between x2i and x3i. Okay. So now if this is the situation, and अगर वो आपने इक्वेशन नहीं लिखी, but I am going to write down that equation. In this case, see, two explanatory variables are there. See, two explanatory variables are there, x2i and x3i, x2i and x3i. So beta 2 and beta 3, beta 2 and beta 3, यहां से वो beta 2 की कोई वैल्यू तो होगी ना फार्मूले की, वो जो फार्मूले की वैल्यू है, द फार्मूला फॉर बीटा 2 इन दिस केस, मैंने पहले भी लिखा था, मैं दोबारा लिख रहा हूं उसको, आई एम गोइंग टू राइट इट डाउन एज समेशन Why it is not working? Summation yi. What's wrong with this? Oh,
सर इंक खत्म हो गई होगी।
चलो मैं दोबारा कोशिश करता हूँ। बीटा 2 हैट और नो, ये असल में वो टच स्क्रीन है ना, तो वो गड़बड़ कर रही है। इक्वल टू, देखो फिर नहीं लिख रहा, क्या क्या चाहता है ये?
सर असल में 3 घंटे हो गए ना, इसलिए शायद
थक गया,
थक गया सर।
मैं तो अगर इसको लिखूं ना माउस से तो ये बहुत टाइम ले जाएगा, मैं चाह रहा हूँ कि इसको मैं अपनी फिंगर से ही लिख लूं, तो नहीं मान रहा मेरी बात। बहरहाल
सर टेक्नोलॉजी की लिमिट होती है ना।
समेशन वाई आई, ये फार्मूला तो आप एक दफा लिखे ना जी, समेशन वाई आई, समेशन सॉरी समेशन वाई आई किधर गया यार, पेन था यहाँ पे, ये तो मिटाने वाला, ऊपर से वो देखे पेन ही गायब हो गया उसका।
सर जुबानी बोले, हम लिख लेते
हाँ,
हैं सर।
आप जरा लिखें, इसको लिख लेना आप,
सर वो आपने
लिखें
जूम किया इसलिए हो रहा है,
सर
जी।
जूम किया हुआ इसलिए हो रहा है, शायद पेन गायब हुआ है।
अच्छा सॉरी यार, नहीं यार 25% पे ही है, जूम का इशू नहीं है,
सर हम जुबानी
कोई और इशू है उसमें, मुझे अब नहीं, इसको इतना वो नहीं है।
चलिए आप
Time
बोले
to
सर।
हम लिख लेते हैं।
we are
हम
not
लिख
in
लेते
to waste our time. You can simply
समेशन वाई आई।
yes, write down summation yi
जी सर।
x2i, you have to multiply this with x2i,
जी सर।
and then summation x3i square
आई स्क्वायर। जी सर।
minus,
जी सर।
let me not say this, अच्छा मैं दोबारा शुरू से बोल रहा हूँ जी, लिखें summation yi x2i multiplied by summation x3i square
जी सर।
minus summation yi x3i
समेशन वाई आई एक्स 3i
यस सर।
multiplied by summation x2i
यस सर।
3i
एक्स 3i।
जी, आप डिनोमिनेटर लिखें, डिवाइडेड बाय
यस सर।
लिखें समेशन x2i स्क्वायर
समेशन
Yes,
टू समेशन x2i स्क्वायर
हाँ जी, x2i स्क्वायर मल्टीप्लाई बाय समेशन x3i स्क्वायर माइनस ब्रेसेस,
जी सर।
और ब्रेसेस में आपने लिखना है समेशन x2i मल्टीप्लाई बाय x3i होल स्क्वायर।
समेशन x2i
जी,
मल्टीप्लाइड बाय
ये मेरे जो है ना इस व्हाइट बोर्ड को कोई मसला हो गया है, आई डोंट नो व्हाट इज।
x3i
हाँ जी, समेशन x2i मल्टीप्लाई बाय x3i होल स्क्वायर।
जी सर।
हाँ, ये बीटा 2 की वैल्यू है, दैट यू कैन ऑब्टेन दिस वैल्यू और यू कैन डिराइव दिस वैल्यू इफ यू यूज मैट्रिसेस। Okay, 3 big equations will be there, and then when you will finally solve it, you will have the value for beta 2 hat as this. Okay, अब ये इशू है कि मैं या तो इसकी तस्वीर लेके आपको अपलोड कर दूं, ठीक है, क्योंकि यहाँ अगर मैं आपको इक्वेशंस लिखवाना शुरू कर दूं तो ये 3-4 इक्वेशंस हैं, आपके यहाँ ना गलती का इम्कान है। So I will inshallah take picture for this because these are the handwritten notes. Okay, I can take picture of this and I will upload this. Simply अब यहाँ मैं आपको बताना क्या चाहता हूँ, ये जो आपने इक्वेशन लिखी है, इस इक्वेशन में you simply have to substitute the value of x2i that is equal to x3i lambda x3i, तो आप यहाँ सब्स्टिट्यूट कर देंगे lambda x3i, और फिर जब आप उसको सॉल्व करेंगे, when you will solve that, the answer will be 0 divided by 0. Finally, you will obtain the answer as 0 divided by 0. So 0 divided by 0 का मतलब 0 नहीं है, 0 divided by 0 means
Infinity.
जी, 0 divided by 0 means infinity, ठीक है ना जी। तो ये जो बीटा 2 हैट की वैल्यू आएगी वो इन्फिनिट हो जाएगी, मेरी बात समझ रहे हैं। तो हुआ क्या कि जब आपने x3
सर 0 डिवाइडेड बाय 0 तो 0 है, इन्फिनिटी तो नहीं है सर।
0 डिवाइड बाय 0 इनडिटर्मिनिस्टिक होता है, वो इन्फिनिटी हो जाता है, उसको आप डिटरमिन नहीं कर सकते, ठीक है। 0 डिवाइड बाय 0 0 नहीं होता, जब 0 यानी से डिवाइड हो जाती है कोई चीज तो वो इन्फिनिटी हो जाती है।
एनीथिंग डिवाइडेड बाय 0 इज इक्वल टू इन्फिनिटी।
अच्छा, तो ये जो बीटा 2 हैट की वैल्यू आएगी जो आपने इक्वेशन लिखी है, इसमें से यानी आपने सिंपली क्या किया, यू सिंपली सब्स्टिट्यूटेड द वैल्यू that you set for x2i. Initially, you said x2i is equal to lambda x3i. Okay. So you substitute the value for x2i in the equation that you have just written, beta 2 hat, in the formula. So you will write down here summation yi, and then for x2i you will substitute the value as lambda x3i. Fine. And then you will solve. The numerator will become 0 finally, and the denominator will also become equal to 0. Okay. So it means that the estimator is, you can say, indeterministic now. Because of presence of multicollinearity, OLS estimator will become indeterministic. ओके, तो ये इशू जो है ये है, अहम है, लेकिन बहरहाल चूंकि ये होता है तो हम इसको किसी हद तक बर्दाश्त कर लेते हैं। ठीक है जी। तो ये मैं आपको इसकी जो पिक्चर है वो अपलोड कर दूंगा उसमें आपकी क्लासरूम में, so you can see it from there. Okay, otherwise I have explained each and everything regarding multicollinearity in detail, and inshallah now we will meet on when we are going to meet now. Okay, now I think
Saturday.
it is sufficient those for today. So meet you in the next class, inshallah. Thank you very much.
Saturday को